In this video, we are going to do a one-tailed test, hypothesis test for this problem. Let's read the question. Question says, define concept company manufactures woolen fabrics at several plants. The weekly production of the woolen fabrics follows a normal distribution with a mean of 200 and a standard deviation of 60. Look at here. So far, I know about the mean of the population, which is 200, and its standard deviation, 16. Recently, due to market expansion, new production methods have been introduced and new employees hired. The mean number of fabrics manufactured in the last 50 weeks was 203.5. Look at here, they have selected a sample of 50 weeks, and the sample mean for those 50 weeks was 203.5. The vice president of manufacturing wants to know if there has been an increase in the number of fabrics manufactured at 0.01 significance level. Look at it in this question. They want to know if there is an increase in the number of fabrics after this expansion. The population mean was 200. Mu was 200. But they want to know if there is an increase in the number of fabrics after expansion. If there is an increase in the number of fabrics after expansion, it means the mu after expansion would be more than 200. Look at here. We are going to test this claim or assumption. So, as you know, the first step in hypothesis testing is to formulate H0 and H alternative. So, and if you remember, we must have the equal sign in H0 in the null hypothesis. But here, mu is strictly more than 200. Mu is more than 200. We don't have any equality here. So we already have H alternative. That's H alternative. As a result, null hypothesis or H0 would be complement of this claim or assumption. What is the complement? Because H0 and H1 must cover all the possible values for mu. When H1 says mu is more than 200, H0, the null one must be mu is less than or equal to 200. Okay? So we already formulated H0 and H1 for this question. The next step after formulating H0 and H1 is alpha. Select alpha. Alpha is already given in the question. It's 0.01. Alpha is level of risk, level of significance, and it's the probability or area of the rejection region. So look at here in this question, we have a one-tail test based on the lesson we learned in the last video about hypothesis testing. Here we have a one-tail test, and based on the last video, we know an easy way to find if the tail is on the right side or left side is to look at H alternative. Here I already have a one-tail test because I don't have exactly equal sign in H0. Okay, so we have a one-tail test, and because H alternative H1 says mu is more than 200, okay, so it means tail is on the right side. If H1 says mu is less than 200, then tail is on the left side. The rejection region is on the left side. It's an easy way to find the tail if the tail rejection region is on the right side or on the left side. So look at here, it's the distribution of X bar, and the rejection region is on the right side. It's on the right side tail, and we know that the area of this tail rejection region is alpha. So alpha is rejection, area of the rejection region, right tail. So far I know the rejection region is on the right side. I have a one-tail test. Rejection region is on the right side, but I need to identify the rejection region clearly. I need this cutoff point. Okay, I need this cutoff point. To find this cutoff point, we need to use norm period S, period inverse, 1 minus alpha in Excel. Okay, so because norm S inverse returns this cutoff point, but this function norm period S period inverse just accepts the area on the left side. Then it returns the cutoff point. But I already have the area on the right side. Alpha is the area on the right side of this cutoff point. So in Excel, I'm gonna enter the area on the left side of this cutoff point to find the cutoff point. Let's go to Excel to find the cutoff point. So look at here. Here I'm gonna find the cutoff point by norm period S inverse. Okay. So, but here I need the area on the left side of cutoff point, 1 minus alpha, 0.01. So the cutoff point is 2.33. So this cutoff point is 2.33. So this step also is done. We clearly identify the rejection region. Now the next step is to find the Z value of X bar. I need to find the Z value of X bar. If the Z value of X bar falls in the tail in the rejection region, I'm gonna reject H0. When we reject H0, it means there is an increase in the number of fabrics, because when we reject H0, it means mu is more than 200. So it means there is an increase in the number of fabrics. Okay. But what happens if Z value doesn't fall in the tail? If Z value doesn't fall in the rejection region, for example, if falls here on the left side of cutoff point, then we don't reject H0. It means that there is no increase in the number of fabrics. Okay. Because H0 says mu is less than 200. Okay, let's go and find Z value. Z, because sigma is known, I need Z statistic to find statistic of X bar. So by using this formula, Z equals X bar minus mu over sigma over square root of n, I can find the Z value of X bar. Okay, X bar is the sample mean. We have a sample of 50 weeks. The sample mean was 203.5. Okay, mu population mean is 200. Sigma is 16. And n is 50. We have a sample of 50 weeks. Okay, so just I need to replace the numbers here. Okay, let's do this calculation in Excel. Look at here, X bar 203.5 minus 200 over 16 over a square root of 50. Let's go to Excel to find Z. First, I'm gonna find sigma over a square root of n, then I'm gonna recall that in Z. Okay, so because it's a part of formula. So sigma 16 divided by a square root of n, 50. So it's sigma over a square root of n. Now let's find Z. Z is X bar 2.203.5 minus mu 200 divided by sigma over a square root of n. So look at Z. Z is 1.55 if we round that to 2 decimal. So Z is 1.55 rounded to 2 decimal. Okay, so 1.55 is on the left side of the cutoff point because it's less than 1.55 is less than 2.33. Okay, so cutoff point is here. 1.55. Sorry, it's Z value. Cutoff point is 2.33. Cutoff point is on the left side of 1.55. Z value 1.55 is on the left side of the cutoff point. So it means Z value doesn't fall in the rejection region. When Z value doesn't fall in the rejection region, okay, we don't reject H0. And H0 says mu is less than 200. So there is a possibility that the population mean is less than 200. So we conclude that there is no increase in the number of fabrics manufactured.